So the next section we're going to cover is a short one on VQL and Yara performance. So just some information on general performance. What we see a lot of is potential issues of high disk I/O, and that is, say, a Yara query that's trying to access the disk a lot and causing potential performance issues. The other one is high CPU use, which is fairly explanatory, and finally high memory use. Now, out of those three issues, I think the disk I/O is probably the worst one, and that is a legitimate concern if you've got, say, a busy server or an extremely busy machine and performance has been impacted by someone scanning or hitting the disk significantly. What I see with high CPU, a lot of the time that comes down to user perception. With modern OSs, even if you have a high CPU usage, you find it doesn't really impact performance on the endpoint with multiple cores and things like that. But we'll cover a little bit on the resource uses that you can run when we do the lab. I'll show you some things that you can add in. High memory use is generally improved by writing better VQL. And we've actually added some capabilities here. For example, when we do a group by in Velociraptor nowadays, that used to previously all be in memory, but now once it gets over a certain size, it actually writes it to a temp file on disk, so significantly improves performance there. As I mentioned, mitigations are built into the platform, and I'll show you some of them lately. But what I want you to kind of get from this session is a lot of the built-in mitigations, you ideally want to be more targeted and work around them. Yara is very heavily used by our users. Mostly I see process-based stuff if you're serious about using Velociraptor. So hopefully people will catch on to some of the bad stuff that I'm talking about in this workshop. And we also see disk usage with performance limitations. And hopefully I can convince you to do better targeting from this workshop. There's lots of Yara-based improvements, and I've actually got some links to some of Florian Roth's stuff and a blog post by Hexacorn that will help you write better Yara rules if you need some help there. But again, what I'm going to iterate here is there is a better way if we can target better and use that concept of pre-filtering, like filter out those rows in VQL, in Velociraptor, before you even get to your Yara scanning. That's kind of the ideal state. So the lab next is VQL and Yara performance. Okay, so into our lab landing page, you can see we have our two tasks and the references that I mentioned. If we open up our tasks, you can see the discussion that I've written on disk queries. And effectively what it's saying is we want to do things like target, and with NTFS queries, you kind of have a bit of a trade-off because you're querying the MFT where it can be faster if you're looking at something that might have unique file names anywhere on the disk, and it's really efficient at finding that top level object because you think of how the MFT is structured. Whilst if we use a path filter on the MFT, because the MFT is structured the way it is, it effectively needs to reconstruct all the paths, and it can be a little bit more intensive to do that. So this is why during the task, I kind of show the example of both of this, and that's what we're going to walk through now. And then I'm going to show the difference between using glob, which is more of a branching search method, and then a very targeted glob query. This particular scenario, I've got some IIS logs from the WSFTP recent CVE, And the reason I'm using this is because it's a really simple kind of exploit. It's a really simple string in the app logs and IIS logs, but it's a really good proxy for kind of using this use case of, we've got a app that could have been compromised, and we want to search for it. We may not necessarily know the location. So the first step that we need to do is deploy locally. And I've actually already run this. So running the PowerShell, it will deploy my files. I also dropped a copy to the desktop because I want to show one of the issues with using a targeted technique might be that you miss things. So I'll show missing some things later. And then after that, we need to start our collection. So I'm just going to copy the Yara rule. This Yara rule is essentially looking for this string in a post request. So it's very specific and very simple. And the reason why I have these variable lengths here between line breaks is a lot of my workflow comes down to wanting to show the whole line in results, so I don't need to go any further. You can see when we run through, we'll have a time of hits option enabled by default in all of the Yara detection content. That's purely for performance. However, my workflow typically is I'll run it once, get the hit, and then target the file or pull the file back for offline analysis in terms of review and seeing all the logs. So the first thing we'll run is the Yara rule, and this is a good practice to kind of figure out what your search terms are. So for me, I'm interested in running Yara, so I'll run Yara, and you can see what you're looking at. And then in this case, we're NTFS, so then the next string I put is NTFS. In the configuration, we'll drop it in here, and you can see the Yara rule there. At the top, was it inet pub as the path, and the file name we're interested in is u underscore, so your typical IIS like logs, and then -log $. Right, so as I mentioned, having this file name entry makes an MFT search super efficient because it's minimizing the amount of rows that we then need to check the path and do the path build for. As I mentioned, we've got number of hits, etc. But the other thing I wanted to cover off was specifying resources, and I covered this in the slides. But CPU limit %, I most of the time will leave that at 100%. Quite frankly, I don't feel it makes much of a difference. During an incident, most customers are pretty happy to take the hit. IO does take a hit, but essentially with IO, you might find people put 200 there. Anything really over 100 doesn't really make much difference. So limiting IO, you need to kind of think about that. But most of the use cases that I would consider running like an IO limit is if we had a critical server that was really IO sensitive. Max execution time from a performance standpoint is set as 600 by default. And that really should be enough for you unless you're doing some really large bulk artifacts that you can look at adding that, or if you're running something custom that you know is going to kind of go over that. But a lot of the time, if you're targeted and smart about your queries, 10 minutes is more than enough. Max rows, again, this is stuff that I don't usually play with because most of it I've kind of taught myself to kind of play within all these boundaries naturally and to be most efficient. The only thing I would recommend is having a play and seeing what works for you. I personally lean on being more targeted with my queries, being smarter with the kind of VQL I run, and also having engagement with my customers or having engagement with the stakeholders who might own the systems, right? Like, you don't want to be running heavy disk-based Yara and hurting your critical business functions when you could simply run like process Yara and have it much easier time in terms of your users complaining. Okay, so I'm not going to use any resources here, and I'm going to launch this, and it will go off and run Yara over the files that we specified. This is the kind of, I guess, trade-off with running NTFS, in that it's really good if you have lots of files that are the same name that you want to scan. But it can be a bit longer because you need to parse the MFT over a targeted glob if you kind of know where you're going. You can kind of see we've been going currently for about, 30 seconds at the moment, and it's finished after 33. So in this lab use case, it's pretty fast. Like, you can't really complain about that. But you can imagine if you're pulling back files from a busier system or a machine that's got a very large hard disk, or changing your targeting here. For example, this is a very specific file name, but maybe if you had just .log that you were targeting, that would mean that you'd pull back a lot more files in that first run of collection. And then the path regex would have more that it would need to reconstruct the path for. But I'll show you running this. Like, let's go to the results first. You can see it's pretty cool in how it presents results. So we've got the log, description, and the rule that we've hit on. This hit context for me is a game changer from a triage perspective. Looking at a log, it's not super valuable, but say you've got a hit on a binary file, you can find it here, you can search through it. By default, we've only returned a small size, just the hit itself. But like I said, that config option, and I'll show you when we walk through it again. If we hit that configure parameter, this config option down here, we can configure more context. We can configure to increase number of hits. At the moment, we're just returning what the hits are, but if we put, say, 1,000 here, it would return 1,000 bytes either side of our hit. So we could then review it. Of course, we also have the upload hits as well. So we could just upload the file. So here, what we're looking at doing is adding in a regex for path, and we need to actually say all files. So you think about how this would be querying the MFT, the file name regex, the object regex. It's saying, hey, return all objects, and then reconstruct their paths to compare it to this. So when I run this, you'll see the difference in terms of performance. I recommend going off and having a coffee, and when you come back, you'll find that this would have finished. Okay, so that looks like it's finished, and it's returned the same hits. In this case, it's gone for 148 seconds. So again, it's not super long. However, if you had a lot more scope in terms of your search, this could be significantly higher. And if you had a lot of scanning on Yara, you had users who were kind of very sensitive to performance impact, that could be an issue for you. The next one we're going to try is another artifact called Yara Glob. Now, what I'm going to do is just copy this collection because this is the easy thing. I want to copy the Yara rule here. So I'm going to copy that, then go back to select artifacts, and then type in Yara Glob. Now, this is generic.detection.Yara Glob. So this is a really good artifact in that it is cross platform compatible. Like you can run this on Linux, you can run this on Mac or Windows, and you can see the examples that I've written here down the bottom to give you an idea for some of the syntax that's compatible. And I use this all the time in engagements. This is my go-to for something like this use case where we're looking at targeting logs. But keep in mind, because it's set to just use the API of the OS, in Windows, for instance, you're not going to be able to find deleted files like you would using that NTFS collection. So I'm just going to copy the rule there. The path glob we're interested in is C ... inet pub ... into u_star.log. So you can see this is using a glob instead of the regex. And this is probably the big difference between leveraging glob or leveraging something like the MFT artifact, in that with the MFT artifact, we're relying on filters of the actual plugin itself. But in this case, the glob is a native argument to the plugin. Exactly the same for everything else. The other thing that is probably worth mentioning as well, if you do have, say you're looking at like a binary use case where you're looking to run Yara and hunt down a binary, adding the size in these use cases is super fast as well. For our log situation, it's not so much a big thing, but just adding a size or a size bound, even a date bound as well, is really useful for keying in on filtering down the amount of rows that you need to work your Yara over. It's much more efficient to do it in VQL than it is to do it in Yara, in Velociraptor. So that's going to go off and run. And I think we'll see that this one is pretty quick. And you can see there, about 28 seconds. So a little bit under this one here. Very, very similar. And of course, we've got the same results here. Mainly, it's just a glob output opposed to the MFT output. So the final thing that I wanted to run in the disk-based Yara section was running targeted glob. And this is where we really, really shine. If you know the path, and you can see the glob here is looking at kind of a choice between either C inetpub or the inetpub folder in this C users some random application. So it's very, very targeted. So when I run this in around 8 seconds, which is impressive. So let's run this again and we'll see if we can pull out all the hits. So we'll add an unreasonably large amount of hits, and then we'll also select upload as well. So this is probably the use case. I think it's actually the use case that I used when I released a detection artifact for this particular CVE. And you can see we've gone up from 6 to 8. It was still blisteringly fast. This time at 1 second. I guess my machine wasn't busy this time. But the thing to remember here is we had 9 down here. So why is the difference? And the difference in that is I actually dropped some of these files to my desktop when I was testing because I wanted to show us missing and using one of the downsides to being really targeted with our collections, right? You miss that kind of generic stuff that the NTFS will always get because of the way it works with looking at the file name primarily. So when we go to results, you can see there's an extra field here because I selected upload. We've got the hits like we had previously, and uploaded files. This is what I was referencing before. So you can see the upload, we've got the hit segment, but also the whole file as well. And when I pivot into there and come here, and you can see, I expand it out to get a bit of view. This is the log view. So it might not be the best site, but you can jump to offset. You can regex for hex string or regex, and do review straight in Velociraptor, which is really cool. The next part of this lab is the memory component. And what we want to do first is generate some data. So I want you to open up a PowerShell ISE. And what this PowerShell code does is it will download a loader that injects into Notepad. So when we hit play on that, it might take a few moments. And then a few seconds before it injects. But how you know it's successful is you'll see on the screen here. When I ran it before and I didn't run cmd/c, it would not print standard out. And if there was an error, we didn't know about it. But there was actually an error with it grabbing the PID too quickly and then it not applying a valid PID here. So I've added the sleep in, so it should work. But if you see an error, what I would recommend doing is just run this section of the PowerShell. Make sure you have a PID there, and then rerun loader.exe and reference the PID, and then that should work. But anyway, after we run this, we'll have a beacon in memory. So the next step is to go back to our machine and collect Yara.process. So what we want to do here is run Yara.process, and we're going to leave it all default to simulate real world. The default rule here is Cobalt Strike, so it makes it really easy. We're going to leave one hit, although there actually is 2 beacons that are injected. And when we launch that, it will go off and Yara scan all the processes looking for that Cobalt Strike Yara. It will take a few moments, so you might want to come back when I finish explaining a little bit. You can see here, here's the errors that I was specifying before. Velociraptor will only have access to processes that the user it's running as has access. So some of these are protected processes. If you run as a non-privileged user, you'll have more processes that pop up with these kind of errors. But this is totally expected. So it should take a couple of minutes. So maybe go off and make yourself a cup of coffee, and it will be ready when you get back. Okay, so that's completed. And you can see just over 2 minutes it took. We have 1 hit. We can come to the results and see details on the process, command line, the rule, and the context, which is nice. But what I wanted to show you was a more efficient way of scanning, right? Especially when you know about the sample that you're looking for. So this particular sample, so I'm just going to hit copy so I can grab that rule. And I'm going to use the VAD again. So this particular sample, we know that it injects into read-write. Now, if I copy this rule, I can then remove it and copy the rule into the suspicious content field. It just means I don't need to mess around trying to copy rules out. But what I want to do is simulate real world, but I know about the sample that I'm scanning for. So the first thing is we're looking for an unmapped section. So I can hit the regex for nothing. And note that's different than a blank. Protection regex, you want to add read write only. It's worthy to note I've kind of added this here into this artifact that is just a quick little selection item. If you want to say select any executable or read write execute, we can run that easily. But for me, when you have knowledge about the sample that you're trying to detect on, this is another way to really make your scan efficient. And the reason for that is because you think about running the VAD on a machine, there is some overhead to run the VAD plugin. But when you think about all the mapped sections that are aligned to a process, when you come around to the Yara scanning bit, to only scan the sections that are unmapped and that particular protection means that you're doing a lot less scanning. So it's a lot more performant, even if you choose to scan over all processes. So this is one of the big points that I try to make. If you know about the sample and you know what it does in memory, literally write your artifacts to take advantage of that. Okay, and here's the results. And you can see we actually have 2 hits, one for Velociraptor and one for Notepad. And this is really interesting because it gives us a really good example of how do we respond to false positives. Now, we know the bottom one is kind of real, but what I'm going to do is rerun this because it was quite fast. And I'm going to increase the context on that. So we're going to get more information around our hits. And this is kind of like real life when you run a Yara scan and you're scanning in memory, and you might get some strings that are flagged by like a security process, like an AV process or something like that. Why the Yara process didn't detect on that is because we come here. In the VQL, we actually filter out itself. So you can see we're saying me, and then we're saying and not me in PID. So we actually filter it out by default there, but in the VAD artifact, we don't. So it's really interesting nuance, and it's actually a really good example to demo what we're looking at here. So some other cool outputs with the VAD artifact is you can see the process chain. So in this case, it's just Notepad, but with the Velociraptor hit, you can see we've got Velociraptor, and then it was loaded by what CMD. It was CMD was loaded by Explorer. So you have a level of triage there. But coming back down here, what we can do is look at the hit context. And I can see already that this looks like our Yara rule itself. So we've been able to determine that this rule has actually hit on the Yara rule in memory, which is a really cool triage capability. So now we've kind of got an idea about what's a legit positive, what's a false positive. We know this is the process we want to target. We might then want to run an enrichment. So I can run Cobalt Strike and carve this out and extract the config out. Here we can do Notepad, or we can even add Velociraptor here too, and you'll find it probably won't return a row. So that's another way. Mind you, you don't have a Cobalt Strike, a carver for other samples you might be running. You need to specifically have a carver for that. Now, you know, there was 2 rows, and when this runs, you can see the results. Both of these hits are in Notepad. More importantly, it was super fast because we were able to determine that we were targeting the processes of interest. So there's a couple of ways to scan memory and have them be more efficient in their scanning, and also triage any hits that you get as well.